there, adventurer, and welcome. I'm NerdTeach, and I am so glad you're here. Today, we're setting off on a really important quest. We're not looking for gold or some magic sword. Nope. We're seeking a power that's way, way greater. The power to look inside the mind of a computer, to understand how it thinks, and, believe it or not, to predict its every move. This, my friend, is the quest to think like a computer.
Okay, I know this sounds a little harsh, but it's probably the truest thing anyone will ever tell you about coding. See, the computer isn't trying to be difficult. It's just perfect. Flawlessly and, yes, sometimes infuriatingly, literal. It only does exactly what you tell it to do, not what you hoped it would do. And that little gap between those two things, well, that's where the embarrassment and all the bugs live. So this is it, isn't it? The great mystery. The very reason you, our hero, have answered the call to this quest. We have all been there, staring at the screen, totally convinced our logic is perfect, but the program just keeps failing. This feeling, this incredibly frustrating puzzle, that's the dragon we're here to slay today. And the secret weapon isn't just typing faster, it's learning a whole new way of thinking. And here's our map for the journey, our official quest log. We'll start by forging our very first spells in the quest to think. Then we'll get our hands on a magic ledger to track all our power. After that, we'll journey through the treacherous repeating forest trail, brave a dungeon within a dungeon, and finally face the mind-bending hall of magic mirrors. If you stick with me, I promise you'll walk away with a genuine engineering superpower.
All right, every great mage has to start with the basics, right? Before we can command the machine, we have to learn the fundamental spells of verification. This is where we get our minds ready for the challenges ahead.
Let's open up your spell book. You've got two really important preparation rituals in here. First up is desk checking. Think of this like checking your entire inventory before a big boss battle. You're looking for any little mistake, a typo in an incantation, just to make sure everything's ready to go. Then you have the pseudo-run. This is like finding a brand new spell scroll. Before you waste any mana casting it, you trace through the logic on the scroll itself to see if the idea even works. They're both about catching problems before they become big disasters. And that brings us to the most powerful spell of all, the dry run. This is the moment you stop being just a coder and you become the machine. You become the human CPU. You're not guessing anymore. You are calculating. You're simulating the code, line by painstaking line, to prove what it's going to do. This is the core skill for our entire quest today. So, how does a mage keep track of all these powerful, complex spells? I mean, you can't just keep it all in your head, right? You need a tool, a special book to record every single flicker of magic. And that tool, my friend, is our magic ledger. Now, to use this magic ledger right, we have to adopt the computer's mindset. This means 3 non-negotiable rules. First, blind obedience. The computer does exactly what is written, not what you were thinking. Second, state persistence. Our potion levels are variables. They only change when a spell explicitly tells them to. And third, and this is maybe the most important, no skipping steps. Every condition is checked, every line is read, every single time. The computer never, ever assumes. And from now on, neither do we.
Okay, and here it is, our magic ledger in action. This is what we call a trace table. Let's trace a super simple spell. We start at the top, the init row. Here, our 2 potion bottles, A and B, get filled with 5 and 10. Now we execute line 1. Let's say line 1 just calculates A plus B, which is 15. Notice, nothing else has changed. The output is empty, and our A and B bottles are still 5 and 10. It's only when we get to line 2, which might say something like A equals A plus B, that our ledger finally shows the variable A is updated to 15. We record every single change, no matter how tiny.
So, the big question is, how do we force our fast-moving human brains to slow down and be this robotic? I'll let you in on a little secret technique. It's super simple. Use your finger, or the tip of your pen, and physically point to the line of code you are on. And here's the rule. You are not allowed to move that finger until you have completely updated the magic ledger for that line's action. It feels a little silly at first, but it forces you to be deliberate and stops your eyes from jumping ahead.
With our ledger in hand, we are ready for our first real challenge. We are now entering the repeating forest trail. This is a place of loops, of iteration. A lot of young adventurers get lost in here because they make assumptions about the path and end up running in circles forever. But not us.
But before we take that first step, I want you to remember something really, really important. As we go through this next section, it's going to feel slow. It's going to feel methodical, maybe even a little tedious. If it feels slow, good. That is a great sign. It means you're actually rewiring your brain to think with the precision of a machine. The best programmers aren't the fastest typists. They are the most patient simulators. All right, let's walk this trail together, one step at a time. Our journey begins, and our step counter, I, is set to 0. We write that down in the ledger. Now we're at line 1. We check the condition. Is 0 less than 3? Our ledger records true. Great, we can enter the loop. We go to line 2, and we output iteration 0. Update the ledger. Then at line 3, I gets incremented. Its new value is 1. We record it. Now we go all the way back to line 1. We check again. Is 1 less than 3? Ledger says true. Okay, back in we go. Line 2, output iteration 1. Line 3, I becomes 2. Back to the top, line 1. Is 2 less than 3? Still true. Line 2, output iteration 2. Line 3, I is now 3. And here it is, the most important step of all. We go back to line 1 one last time. Is 3 less than 3? No, it's not. The ledger records false. And only now, with that false written down, do we finally exit the forest. We didn't assume anything. We proved it. You've made it through the forest. That's huge. But what happens when the path leads you deep underground into a dangerous dungeon that has another, smaller dungeon hidden inside of it? This is the world of nested loops, and in here, every single detail matters. Now listen close. A word of warning before we go in. So many adventurers get lost in here, and it's always for the same reason. They forget the single most important rule of this place. The inner dungeon, that's the inner loop, it completely resets. Its memory is wiped clean every single time you enter it. Forgetting this is how you get trapped. Okay, let's trace our path carefully. Our outer loop variable tries starts at 1. We're at line 4. Is 1 less than 3? True. We step into the outer dungeon. Now, line 5. We initialize our inner loop variable, count, to 0. Watch the ledger. Now we check the inner loop's condition at line 6. Is count, which is 0, less than tries, which is 1? Yes, it's true. So we go inside, add ghost to our manuscript, and increment count to 1. Now we check the inner loop again. Is 1 less than 1? False. So we exit the inner dungeon. We finish the outer loop, and tries is incremented to 2. And here we go. The second pass. We loop back to line 4. Tries is now 2. Is 2 less than 3? True. We enter the outer dungeon again. And here it is, the critical moment. Line 5. Count is reset back to 0. See it in the ledger? The inner dungeon's memory is totally wiped clean. Now at line 6, we check the inner condition. Is count, 0, less than tries, 2? True. We go in, maybe add warlock to the manuscript, and increment count to 1. Check again. Is 1 less than 2? Still true. We go in again. Finally, count becomes 2. Is 2 less than 2? False. We exit. That reset right there on line 5 is everything. We've faced down loops, we've navigated dungeons within dungeons, but our quest's final challenge is probably the most baffling of all. We are now entering the Hall of Magic Mirrors. This is Recursion, a spell that calls itself, creating reflections inside of reflections. It's super easy to get lost in here, but don't worry, we have a tool to guide us through. The secret to surviving the Hall of Mirrors is to stop thinking of them as mirrors and start thinking of them as a tower of pancakes. It's called the call stack. Every time a function calls itself, you put a new pancake on the stack. So fact3 calls fact2, plop a new pancake. Then fact2 calls fact1, plop another pancake. When you finally hit the end, the base case, in this case fact1, you stop adding pancakes. Instead, you take the top one off and hand its result down to the pancake below it. Let's watch this happen in our magic ledger. First, we call fact3. Look at the stack state column. One pancake, fact3, is on the stack. The condition n less than 1 is false, so its action is to call fact2. Now our stack has 2 pancakes, fact3 and fact2. For fact2, the condition is still false, so its action is to call fact1. Our pancake stack is now at its tallest, 3 pancakes high. Finally, inside fact1, the condition is true. We've hit the base case. This is the winding phase, building the tower up. Now the unwinding begins. Fact1 returns the value 1.
And look at the stack. That top pancake is gone. That one gets passed back to its caller, fact 2. Now, fact 2 can finally finish its job. It calculates 2 times the value it just got, which is 1, so it gets 2. It returns that 2, and poof, its pancake is removed. Finally, that 2 is passed all the way back to our original call, fact 3. It can now resume calculating 3 times 2, which is 6. It returns the final answer, and now the stack is empty. The mirrors have all resolved.
And just like that, you've done it. You have braved the darkest dungeons and the most confusing halls of logic. You've completed the quest. But what was this all for? This wasn't just some abstract exercise. You have forged a real-world, incredibly powerful engineering superpower.
You have seriously leveled up. You don't have to just guess and check to find bugs anymore. You can find them with pure thought, just by simulating the machine. You can walk into a technical interview and trace a complex algorithm on a whiteboard with total confidence. You can prove to yourself and to others that your logic is solid. You've made the huge leap from being someone who just types code to being someone who truly understands how computation works. You are an algorithm simulator.
This skill, the ability to do a dry run, is really the line between a novice and a professional. It's the art of slowing down so that, in the end, your programs can run correctly and fast. So the next time your code fails, will you guess or will you know? Thank you so much for joining me on this quest.